Welcome! The best way to understand how Zebrium can help technical support teams is to see it in action. We offer SaaS and on-prem versions of our technology, but the challenge with on-prem is that when there's a problem, we can't just log in and see what's happening. So what usually happens is that some initial troubleshooting is done by asking the customer a bunch of questions. And if that doesn't get anywhere, inevitably, we ask the customer to send us a set of logs. You know the drill. Once you get the logs, someone needs to painstakingly hunt through them and figure out what happened. This can take hours and often requires escalating to other team members. But not anymore. Let's see what happens when you use Zebrium machine learning to do the hard work. The following happened to us recently. One of our customers contacted us via Slack. Customer, our notifications have stopped working. When was the last time you saw one? Wednesday at 7:22. Did you change anything? Don't think so. What should I do? And here it comes. Can you send me the latest log bundle? As soon as we got the bundle, we ran a small script that unpacks it and uploads each file to our platform. Our bundles contain about 25 log files. About a minute later, 3 root cause reports appeared in the Zebrium portal. This is the summary view, showing what the machine learning found in the log bundle. The goal of the summaries is to allow you to determine the relevance of each report at a glance. The word cloud highlights a few words picked out by the machine learning as being important. Immediately, you can see outbound notifications and critical, which both sound very relevant to the customer problem. Next, we provide a plain language summary. To do this, we use GPT-3. Although this feature is experimental, it often produces very effective summaries. This one says something about an email list column not being present in a notification table. Again, it sounds relevant. And then we show you a few key log lines from the report. In this case, it gives you a good sense of the problem. I'm going to click on the summary to see the full report. On the left, you can see that the core report is made up of 12 log lines. These were picked out of several million that were in the bundle we ingested. They span 3 different logs from 2 hosts. The events tell a complete story. The first few lines show the notification reports being prepared. Then, there's an alert saying email list column is missing in the database, and the reports can't be sent because it couldn't retrieve the email list. Just from these events, we got a clear handle of the problem, and this was enough for us to build a quick patch script for the customer, and the alert started working again soon after. Case closed. Although we don't need any more detail for this one, we do provide some useful controls for interacting with the report. Over here, I can zoom in to see more errors and anomalies that surround the core events. This often uncovers additional useful information about the problem. We can also peek to see other events in any of the individual logs. This is showing the Zmux log. Now here's the interesting thing. Remember that the machine learning found 3 reports. These are proactively generated based on the patterns in the logs. Look at this one from Wednesday, November 3rd. Remember how the customer said that the alert stopped working on Wednesday? Seems like an upgrade took place on Wednesday night, and it failed to update a database table. Sounds familiar. Let's take a look. And this logline explains what happened. There was a failure during the upgrade because the table T outbound notification doesn't exist. From that, we immediately figured out the problem. The reason it doesn't exist is because the table is actually called T outbound notifications, plural. There was a syntax error. The upgrade script was missing an S. Now we knew why the problem happened in the first place. But wait, there's more. We allow user to annotate the report, which I'll do here. And then I can send this report as a bug to our engineering team by sending an alert to Jira right from inside the report. Now that you've seen what the technology can do, Let me explain how it works. The most important thing to remember is that the machine learning is completely unsupervised. You don't need to create any rules or perform any special configuration for it to work. To start using Zebrium, you simply need to start streaming or uploading your logs, and it achieves accuracy even with very small amounts of data. We use a multi-layered machine learning approach to analyze the logs. It starts as soon as logs are received. The logs can be from any application or type of infrastructure, and you don't have to tell us about the formats or set up any parsing rules. The first layer of the machine learning is the most important. It uses unsupervised machine learning to structure and categorize the log events. Quick side note, it does very well even for new or very rare log events. And this turns out to be important because identifying new and rare events is extremely useful when trying to find the root cause of a problem. Once all the events have been categorized, the next layer of ML learns the patterns for each type of log event. This continues to improve as it sees more data, but even a small number of log lines is enough for it to get a good baseline. Now, as each new event is processed, it is given a score based on how anomalous it is. There are many things that go into anomaly scoring, but the two most significant factors are how rare the event is and how bad the event is. That is, events with higher severity get higher scores. Another side note, even though this type of anomaly scoring is very accurate, the results can still be very noisy, simply because the logs themselves are very noisy. So, the next layer of machine learning takes care of that. It looks for clusters of correlated anomalies across the logs. This is what allows it to find the core events that make up a root cause report. And in real-life production, we are seeing greater than 90% accuracy in being able to pick out the right log events that explain the root cause. Next, we use GPT-3 to generate a plain language summary of the problem. We also generate the word cloud at this stage. And finally, this is all put together into an interactive root cause report that is available in the UI. Using Zebrium in your own environment has never been easier. Zebrium integrates with almost any kind of CRM, bug tracking, or other application via a comprehensive set of open APIs, as well as many built-in integrations. Let me end by showing you a really cool example of a Zebrium integration. Remember earlier, after the ML found the upgrade script issue, we chose to send the details to Jira so engineering could take care of the problem. Well, this automation also works if the same problem is detected again. So, a few weeks later, another customer with an old build contacted us about an alert problem. We immediately asked them to send us a log bundle and ingested it as a new case. A moment later, we got an alert from Jira. The same bug had been hit, but this time we didn't even have to open up the root cause report. All the details were right in front of us. Everything was completely automatic. Imagine that, the ultimate form of technical support. A customer hits a problem and the case is automatically deflected and resolved without a support engineer having to do anything. Using Zebrium to analyze log streams or bundles is easy. Visit zebrium.com to learn more or sign up for a free trial. Thanks for watching.